Hello everybody, today we shall see on how to implement parallel processing on a merge sort algorithm to make it more efficient. To understand the intuition between parallel processing, we shall see how a traditional merge sort works. So given an array 73528 we should first split the array into two halves. And the second half would be, now we will further split this into two halves. And even this into two halves. This will further be split into what? It will be split until there's only one element in the box. Now that we split this array, we have split the array until it becomes an array of 1. Now we shall merge it back. So when we're merging it, we compare each array and we will check which should come first. So here, since 7 is greater than 2, when we merge it back, it will be 2 greater than 7. Oh, let's see. Since 7 is greater than 3, first 3, then 7. Similarly here, you will get 2, then 5. And here we will get 1 and 8. And we will combine these two arrays again. First it will check if 2 and 3 is greater. Here since 2 is greater, first it will be 2, then it will be 3, then it will be 5, then it will be 7. And here you will get 1, 6, 8, and 9. Finally, when we merge the last two arrays, we get 1, 2, 3, 5, 6, 7, 8, and 9. So this is a parallel merge, sir. So we split the array into half until it reaches an array size of 1 and we add it back. So how do we split this in half? This will be using a recursion. So this uses a recursion program where we'll have two functions. One is merge. Recursion. It'll have two functions. One is merge and one more is serve. merge sort. So the merge sort will be doing this part. It will split all the elements, while merge will add them back into the same array. So it has an efficiency of O of n log n, but we can make it even more efficient by parallel processing. So here when we are seeing in the program, it runs each step sequentially. So first it splits all these elements and comes till here. Then afterwards it would go here and split all these elements. But instead of uh, doing this sequentially, such as first this, then this, we could make the program do both at the same time. So it would run, instead of going 1, then to 2, it would run and 1 and 2 at the same time. This will make it even more efficient by making it can happen into O of n log n by 2 because we are reducing the step by half. So n log n by 2. This will make it even more efficient as it's splitting it into half and we're giving it to work at the same time. So we will get we will get two works done at the same time. This is the intuition between parallel processing and a merge sort. So how can we implement this in a program? For this, we have an API called OpenMP, which supports multi-processing in C, C++, Python, and many more languages. We shall see the code behind this. So now we shall see a code on how this parallel processing works. So the program includes a parallel merge sort algorithm using OpenMP to efficiently sort a large array of integers. It includes a sequential merge sort implementation for as the base case for smaller subarrays. Example around 1000. The function merges two subarrays into a single sorted subarray, and the program reads the inputs from a file named numbers.txt and stores them in an array. After sorting, it prints the execution time in the parallel mode, and in a sequential file, it will print the time in sequential mode. The merge parallel uses OpenMP's parallel sections to divide the array into subarrays and sort them concurrently, as in it will run this function and this function at the same time. So the merge in parallel processing should be more efficient than the sequential version for large data sets. Whereas here we do not have that function, we just have a normal merge. And how will we generate the numbers at txt? We have a Python file that can run the number of the integers in a file. So for now we set it as 2,50,000 and A and B are the range of how many inside the file how large should the number be. So now we shall run this file, and now that we run the file, we shall see the file. The file is numbers.txt. So as you can see, it takes first the input of how large, what size of the array, and that's a really large file. Now we shall run merge sort is sequential and parallel. To run the file, we shall compile both the files, merge sort parallel and merge sort sequential. Now when we run it, we can run it with this function, where first we would call this exe of sequential, then the parallel. So the sequential gives around 98 milliseconds. That's almost 1.1 second, and parallel gives around 64%. So we can see that the sequential, even though it is the most efficient program in login, it can only go up to 90. It takes up to 98 milliseconds. Whereas the parallel mode is even more efficient because we use parallel merge. And as we can see the efficiency This is around 98 divided by 64. So it's around 1.53. So that means it's 50% faster than a general merge or sequential. So thanks for watching the video. I hope you enjoyed this video. Bye bye.